Now I'm going to show that the rational numbers denoted by Q are dense in the real numbers, which are denoted by R. So this is equivalent to showing that for all x and y in the real numbers, such that x is less than y, there exists R in the rational numbers such that x is less than R is less than y. So we'll start by assuming, without loss of generality, that x is greater than 0. Then we have x is less than y. This implies y minus x is greater than 0. Then by axiom of Archimedes, we have y minus x is greater than 1 over n is greater than 0 for some n which is a natural number, and that's by axiom of Archimedes. And then we can multiply by n throughout, so then we get ny minus nx is greater than 1. It's greater than 0, and this is equivalent to saying that ny is greater than nx plus 1. Now, for the second part of the proof, we're going to recall that for any real number, which we're going to call nx, it lies between two natural numbers. So this would be m and m plus 1. And it's natural numbers in this case because we made x positive. And the same thing would work with integers if x could be negative. And so then we're going to take this part and we're going to add 1 to both sides. We have m plus 1 is less than or equal to nx plus 1. And now putting this together with what we had earlier, we can write that nx is less than m plus 1. And it's also going to be greater than or equal to nx plus 1, which is less than ny. We can rewrite this as nx is less than m plus 1 is less than ny. Divide through by n. X is less than m plus 1 over n is less than y. And now we have found this is R, the rational number. We know it's a rational number because it's a natural number divided by a natural number. And so this is in Q. And we're done. We found a number in Q that was between two numbers x and y in R.